And we're live.
Right?
Huh?
These are functions, right?
Yes.
Or relations.
Yes, we're gonna write equations. So the input gives an output, and then that output goes in as the input and gives you a new output. So absolutely. Sequence is just a ordered list of numbers, okay, with any type of pattern that you want to throw in there. Okay, your terms are the numbers that are in it. So, for instance, this is your first term, your second term, your third term, your fourth term, so on and so forth. Okay, does that make sense? Everybody good? So, back to the patterns that we just got done doing. What is the pattern in number one? What is happening? Plus 2. So, our pattern is to add 2. Number 2, we go from 4 to 12 to 36. You said what? Times 3. All righty then. All right, figure out 4. Oh, yeah. One of y'all are going to get it. One of us got to get it. You think you got it? So you can explain yourself. Mm-hmm.
Although it is right.
It is right. That's going to be too complicated of a pattern. What you're trying to find is the same thing that's going to happen over and over and over again with these ones. It does.
That's what's
Oh, I thought you had an idea.
Oh, I think I got it.
Oh, you think you got it now?
I don't know.
Oh.
Alright,
What you got?
First one is -2 plus 7 and then -9.
That's what he's doing.
That's
what he's doing. Okay, so far we've got, you said -2.
plus 7.
Okay, so we've got -2 plus 7 -9
Plus 16.
plus 16.
Yeah.
There's really no pattern happening here yet.
Give me time.
I am giving you time. The funny part is when I usually give you the pattern, you're like, oh, it was really that easy?
Is it like multiply and then like?
No, it's one thing happening over and over again.
What?
It is one thing happening over and over
So
again.
like one thing is in like.
So,
like
I want
add-
you to think about, go back and think about the ones where you had to take, think about the ones where you had to go back and take 3 plus 4 gave you 7.
Oh,
4
you add them
plus
together.
6. You don't add
Subtracting
them.
them.
You subtract
I
them.
knew that.
So,
Yeah.
-3 minus -5.
Oh.
What does that minus and negative do? It makes it a positive.
I knew that.
So that gives you +2.
Man.
-5 minus 2 gives you -7. So your pattern here is to subtract the previous 2 terms. Okay? Subtract the previous 2 terms.
I did that on my calculator, but I ain't put the parentheses. That's why I got it. Smart. Why are you supposed to put this?
So you did -3 minus -2?
Yeah. Wait.
Even
plus negative 5.
Yes. Yes.
Did you do plus -2 instead of minus -2? Or did you do minus?
Like when I was doing it, and
You were adding them instead of subtracting them.
that's why.
Yeah. Because without the parentheses, it still would have changed that minus negative to plus a positive. Okay, so specifically in this unit, we're going to talk about recursive sequences. So the problem with recursive sequences is the terms in the sequence are based using the previous terms. So the issue with recursive is you need to know what happens before you can continue on. If they don't give you enough information, you're stuck. Okay? In the next chapter, we're going to talk about explicit formulas instead of recursive, which makes it a little easier. And this is the section where you're going to be given a formula sheet on your test. So I will give you the formulas for this. Okay? So, the recursive rule is the mathematical sequence or the mathematical statement for the pattern of the sequence. Okay. Specifically, we use the word seed. Think about it. Plants. What do you have to do to grow a plant?
Water.
Water it. What do you need first before you do that?
Seed.
You need that seed. So in math, seed is the first term. Okay? It's what you need initially. You need a seed to grow a plant. Okay? Plants don't just poof out of midair. Okay? Sequences don't poof out of midair. You need a seed. You need the first number of the recursive sequences that are used to begin the pattern. Okay? So, we're going to talk about how we notate things. A sub n. This is a term. I don't remember what fills in that blank.
Is it used?
I just had a moment. Now you're going to make me look it up because I can't think of what goes in that blank. Sorry, y'all. I'm having a moment. Moments happen. I really don't know what that specific word is that is stuck in there. Oh, Jesus. There we go. The term value, that's what I'm looking for. Okay, so, for instance, if you're given the pattern 2, 6, 18, okay, if I'm looking for A sub n, 6 would be A sub 2.
Oh,
Okay.
It's the second.
Because it's the second number in the sequence. 18 then would be A sub 3. This is A sub 1. Okay, so that n value tells you the term location in the sequence. It tells you where your number is. If it's in the third spot, it's A sub n. Okay, they use A, and it's just a variable that names the sequence. So I can have a sequence that is B. I can have a sequence that is T. Okay, they can just pick any random number to name your sequence. So what everybody gets stuck on is this. Okay, so if I label 18 as A sub n, okay, if I need to go backwards one step and use that number, the way we denote that is A sub n minus 1. You're going one step backwards and using that number. If I need to go back and use this one to find this one, how many spaces am I going backwards? 2. So guess what? This is A sub n
Minus 2.
minus 2.
Why would you use that? Like,
So that's what leads us to this. So if I need to write a sequence that goes with number 1. So we're trying to find the next term in the sequence. So my sequence is A. So you always start your equation with whatever sequence you are in A sub n. That's what we're trying to find.
so A equals 3 times A minus 1.
Okay, so
N minus 1.
equal to 3 times the previous term. So literally 3 times, and you need to know how to write the previous term. Well, again, if I'm here and I only need to go 1 step back and use this number, I call that A sub n minus 1. So what you've done there is you've said, at this point, because this is exactly the one it is, if I need to find this one, I go backwards 1 and multiply that by 3. So this would become my new A sub n, which then in turn makes this A sub n minus 1, A sub n minus 2, A sub n minus 3. Does that make sense?
Based on where you start.
It's based on where you start. So if I started, let's say we have 1, 2, 3, 4, 5, 6, 7, and I'm here at 6, that means the 5th one is A sub n minus 1.
All the way down to.
This is A sub n minus 2, A sub n minus 3. Okay, it's telling you how many spaces you need to go back to use those numbers.
The one on the right would be A sub n plus 1.
Absolutely.
Okay.
A sub n plus 1. Okay, so A sub n is your starting point, and then the minuses tell you how far to go back to the left. If you had to use plus, it would tell you how far you need to go to the right. Okay, but with recursive, you're not going to use the plus 1 because recursive means you go back to the previous. Okay, so number 2, the pattern B. So now instead of calling my sequence A, we're going to use B sub n because that's what it tells me my sequence is. It's labeled as B. Okay, so it tells me I need to multiply the previous 2 terms.
A n minus 2 times A n minus 1.
Okay, so this tells me I need to go back and use this one, 2 spaces back from where I'm at, and this one, 1 space back from where I'm at, and I need to multiply the 2. So I literally use B sub n minus 2 times B sub n minus 1. I need to go back to the 2 terms away and back to 1 term away. Okay, number 3. This time, my pattern is used to U. U sub n. Okay, it tells me I need to use the previous term. So previous term means 1 step back. So if I'm at U sub n, previous is U sub n minus 1. Okay, then what? Plus 9. Plus 9.
Over 4.
All over 4. All over 4.
How long have you wrote unit?
Okay. It does kind of look like I wrote unit. Okay. Number 4. How do I start this one?
A equals.
A sub n. Don't forget that sub n, Marcus. That will kill you every time.
Okay. Then you use parentheses. Well, I put mine.
No.
Okay. A n minus 1 times 2. Or A n minus 1 times 2. That's fine. That's why I put it in parentheses.
See. Okay. So it's 5 less than. When I see that word than, I always go and do what is second after than first. So how do I write double the previous term. How do I double something?
Times 2.
Times 2. 2 times the previous term. How do I write it?
A minus 1.
A sub n minus 1. Okay? And then 5 less than that is minus 1. Simple as that.
Can we put that in the parentheses?
You don't have to.
But we can, though, right?
You can.
Okay.
Because I have an issue with some people write 5 less and they do this.
Oh, they put the parentheses on
Okay. So I have a problem with some people writing this. Remember, 5 less is 5 off of it. Okay. It's not 5 minus. So watch your wording.
less than double.
Right. It will catch you every time. That's why when I see the word then, I do everything after then and then go back to what happens at the beginning. Okay. All right. We almost done. We got that backside and we finished for today. Okay. This time, they give you the equation. They give you your seed. They tell you A sub 1 is this. Find the next 3 terms. So the first thing you want to do is write a verbal statement. What is the equation telling me I'm doing to my numbers? So if I have A sub n equals A sub n minus 1 minus 3, what is happening?
So that means like A2 would be 25 minus 3. Right?
Okay, so this says the previous term minus 3. Okay, you take each previous term and you subtract 3 from it. So,
What's the
previous term. So, if I start at 25, I need the next 3 numbers in my sequence. Where am I going? 22, 19, and 16. Okay, take a look at the equation in number 2. What is that telling you we're supposed to be doing?
Multiply 4 by previous number.
Good. 4 times u sub n minus 1. Well, u sub n minus 1 means I need to go back 1 number and multiply that by 4. So this is 4 times the previous number. Or the previous term, however you want to call it.
So
Okay.
previous term times 4.
Previous term times 4 is fine as well. Okay? So if I start with 3, 12, 48, 192. I knew it was something too. Okay. Number 3. What is that telling me to do?
It's letting you multiply 4 by the previous term.
4 times the previous term plus 1. Okay, so if I start at 5, 21, 85, 341.
Smith,
Yes, sir.
I have, oh, no, I have it.
Who?
So you don't have.
Fantastic. Number 4. What's that telling me? So 3 times the previous term minus 11. We start at 6. 7. I like the mental math there, Trey.
10.
10. 7 times 3 is 21 minus 11 takes me to 10. 19. 3 times 10 is 30 minus 11 is 19. And finally, number 5.
7 minus double the value.
7 minus double the previous term. Okay, you could have also written 7 minus 2 times the previous term. Okay, 2 times and double mean the same thing. So if I start at -1, where does that take me to? Remember, it's 7 minus 2, and you're plugging in a -1. Not -9, +9. -2 times -1 makes this a +2 plus 7 gives me 9.
You say that part again?
-2 times -1 makes this a positive.
Right.
So that's +2, and put that with 7 gives you a +9.
Okay.
Wait,
Okay.
Wouldn't it be 6 then?
Okay, so now I'm plugging
Since it's
in,
not a -2.
since I'm plugging in a 9 now. -2 times 9 gives me what?
Negative 18.
-18, and then a +7 takes it to
-11.
-11. Okay, so these are going to go back and forth between negatives and positives. So now I'm plugging in a -11. So that gives you +22, and 7 takes me to 29. Last little bit at the bottom. Okay, so we've got special types of recursive sequences. The first one is an arithmetic sequence. Yes, looks like a right. But they pronounce it arithmetic when it is a sequence. So arithmetic means you've got a pattern of addition or subtraction. But what is specific about it is it has to be the same number added or subtracted over and over again. So you can't do +2 minus 3. Okay, it has to be +2, +2, +2, +2. -7, -7, -7. So the number that you add or subtract is called your common difference. And they denote that by D. So the recursive rule for any type of arithmetic sequence is always A sub n equals A sub n minus 1 plus D, whatever your common difference is. So it's always what comes before it and add or subtract what happens. So if you look at the examples here, we need to find the common difference, and then I want you to write the rule. So you said this is +17. That's my common difference. So D equals +17. So when you write this as a recursive rule, A sub n, the previous term, so A sub n minus 1, +17. It's as simple as that. Okay, so it will always start A sub n equals A sub n minus 1. Go back to the previous number that I've given you and add 17. Number 2.
So which way are we gonna, do we have to write it both ways every time?
What do you mean both ways?
Like, are we gonna have to write the D equals and then A plus N, A equals N?
I mean, you're going to need to find the D first
Right.
before you can do anything. And usually on the test, I ask you what's the common difference and then write me the recursive rule. So, okay. So example number 2, what's happening?
A equals 2.6. We'll subtract.
Okay, so -2.6. So technically, this should be written A sub n minus 1. You can either write this as plus -2.6, or I will even take it as minus 2.6. Okay, I don't care. And finally, example 3. I briefly see a shotgun. You said what?
Plus 3.3.
Plus 3.3?
8.
3, 8. What's an easy way to find your common difference?
Subtract the second one from the first one.
Take this minus this, okay? And that will give you your common difference every time if there's an arithmetic sequence.
Wait, what?
Okay? Your second term minus your first term. Or you can do your third term minus your second term. So pick a term and subtract what comes before it, and that will always give you your D value.
Oh,
Boy.
Okay? So this is A sub n equals A sub n minus 1 plus 3.38. Okay? So arithmetic is always adding or subtracting a constant value. Geometric is multiplying a constant value.
Times 5.
Okay? And again, it's got to be the same number over and over again. And they call this your common ratio. Okay? It's called your common ratio because sometimes it's a fraction, and a ratio is a fraction. Okay? So they denote it by R. So your recursive rule here is A sub n equals R times A sub n minus 1. You need to find that common ratio, and that's what you multiply your previous term with.
so 15 times 8.
Okay? So, example number 1. Lewis, what did you tell me my pattern was? Times 5. So, R equals 5.
A sub n equals.
So, this is A sub n equals 5 times A sub n minus 1. So, whatever you're multiplying by just goes straight in front of your previous term. So, what about example number 2?
1.7.
1.75 is my R value. So A sub n equals 1.5 times A sub n minus 1. Okay? What's the easy way to always find your R? Divide. So to get your R here, you would take 56 divided by 32. Okay, so that's your trick there, Trey.
Arithmetic is
Subtract the 2.
and geometrically divide.
Right. Okay, so you could have done 98 divided by 56 or 171.5 divided by 98. You always, whatever number you want, divided by what comes beforehand. Okay, so example number 3. What we get?
0.5.
0.5.
0.5.
So A sub n equals A sub n minus 1. Whoops, 0.5 times A sub n minus 1. I'm thinking I'm doing arithmetic here. 0.5. What's another way to write 0.5?
Half.
1/2. Okay, so you can also write it as 1/2 times A sub n minus 1. Okay, either way works. Questions, issues, problems?